Still chapter 1, thinking about data systems. We typically think of databases, queues, caches, etc. as being very different categories of tools. Although a database and a message queue have some superficial similarity, both store data for some time, they have very different access patterns, which means different performance characteristics and thus very different implementations. So why should we lump them all together under an umbrella term like data systems? Many new tools for data storage and processing have emerged in recent years. They are optimized for a variety of different use cases, and they no longer neatly fit into traditional categories. For example, there are data stores that are also used as message queries like Redis, and there are message queries with database-like durability guarantees like Apache Kafka. The boundaries between the categories are becoming blurred. Secondly, increasingly many applications now have such demanding or wide-ranging requirements that a single tool can no longer meet all of its data processing and storage needs. Instead, the work is broken down into tasks that can be performed efficiently on a single tool, and those different tools are stitched together using application code. For example, if you have an application managed caching layer using Memcache or similar, or a full text search server such as Elasticsearch or Solr, separate from your main database, it is normally the application code's responsibility to keep these caches and indexes in sync with the main database. There is an infographic here. Figure 1.1 gives a glimpse of what this may look like, and we will go into detail in later chapters. I will insert this infographic. One possible architecture for a data system that combines several components. When you combine several tools in order to provide a service, the service's interface or application programming interface usually hides those implementation details from clients. Now you have essentially created a new special purpose data system from smaller general purpose components. Your composite data system may provide certain guarantees, like the cache will be correctly invalidated or updated on writes so that the outside clients can see consistent results. You are now not only an application developer, but also a data system designer. If you are designing a data system or service, a lot of tricky questions arise. How do you ensure that the data remains correct and complete even when things go wrong internally? That's a good question. Maybe take some time, stop, and think about that. Like write your answer down to that question. How do you provide consistently good performance to clients even when parts of your system are degraded? How do you scale to handle an increase in load? What does a good API for the service look like? There are many factors that may influence the design of a data system, including the skills and experience of the people involved, legacy system dependencies, the time scale for delivery, your organization's tolerance of different kinds of risk, regulatory constraints, etc. Those factors depend very much on the situation. In this book, we focus on 3 concerns that are important in most software systems. Reliability. The system should continue to work correctly, performing the correct function at the desired level of performance, even in the face of adversity, software faults, and even human error. See reliability on page 6. Scalability. As the system grows in data volume, traffic volume, or complexity, there should be reasonable ways of dealing with that growth. See scalability on page 10. maintainability. Over time, many people will work on the system, engineering and operations, both maintaining current behavior and adapting the system to new use cases. And they should all be able to work on it productively. See maintainability on page 18. These words are often cast around with a clear understanding of what they mean. In the interest of thoughtful engineering, we will spend the rest of this chapter exploring ways of thinking about reliability, scalability, and maintainability. Then, in the following chapters, we will look at various techniques, architectures, and algorithms that are used in order to achieve those goals. Oh no. What the hell happened now? Did it die?